So this is a momentum operator which has eigenstates like p prime cats, and there is a boost operator like this which acts on a state p prime, which is the eigenstate of momentum operator, and translates by an amount dp prime. So we need to show that this kind of form where the w is a Hermitian operator, it satisfies all these aspects like unitary, associative, and inverse properties, and these are the appropriate conditions for such kind of an operator. And then we need to find the w explicitly using the dimensional analysis, and later we'll show that this relation holds, and later we will derive the matrix element of this type of product. Okay, fine. So let us start with this. So we know that from unitary p b dagger and also b dagger b, this is 1. So if we look at b dagger b, it gives us 1 plus I, sorry, it is 1 minus I w dagger on b prime, sorry, w b prime. This will give us 1 minus I w b prime because w is Hermitian, so w dagger is w. This one is 1 minus I square is w square b prime square minus I w minus w prime. So this is roughly 1. And this is order of dp prime square, which is almost 0. B dagger b is almost 1. Next, okay, we have associative. So again we can say this is something like this, plus the term is prime square, it's almost 0. I can always interchange these terms. Which is nothing but first translating by dp double prime and then dp prime. So the associative is also true. Next is inverse. So bp prime is what? Psi w dot dp prime. And what is negative of this? 1 minus IW prime, which is B dagger, and since we know that BB dagger is 1, so we can say that B dagger is B inverse. Okay, so the inverse property also holds, and you can look at that carefully, that if I take B prime, BP prime tends to 0 on B, it is 1, right? So this also is somewhat meaningful. So our definition of such operator seems to be meaningful in the sense that we have previously demanded for momentum operator. Okay, so what is next? So we have proven all these properties, and now we have to use dimensional analysis to express W in terms of position operator. Okay, so since B is 1 plus IW dP prime, W must have dimensions of inverse of the momentum, and we know that dimension of H bar is dimension of momentum, dimension of position. Okay, so we can say that momentum inverse can be written as there is position, there is H bar. So you can say that this is X upon H bar, or in terms of operators, X upon H bar. So you can write B as 1 plus I X B prime upon H bar. Okay, so this is how we can write B. Okay, so it is the, okay, we need to check the commutator relation, and well, that will hold true because, okay, we know that kind of relation. This holds true. We know that because XP is equals to IH bar. This is known to us. Okay, so finally we need to find an expression for this. What does this mean? Okay, so this is something interesting. This P prime X and alpha. So let us say for time being I am using a slightly different notation for simplicity. So this will be H bar, and I want to see okay, so we know that P1 operator on P prime gives P prime times P prime. I would like to see now that if I do B dagger P B, what will be the cumulative effect? So B dagger is 1 plus I x h bar p sorry okay minus so 1 plus I x p h bar. So if we do the 1 plus keep in mind that order matters here. As we move forward, so we p I p x h bar so I x h bar plus p plus to the order of a prime square, which is roughly 0. So this will be p plus I prime h bar x. Okay, so this will give us p plus I prime h bar p plus a prime. Okay, so this shows a little bit more cleaner what we are trying to do, that if I have a momentum operator and then there is B operator like this that we have proposed here, we can write it like this also. There is B A prime, there is B dagger A prime P B not A prime operated B prime. Why we can do this? Because this part here is basically unit identity, so this part is same. Okay, so if we move forward, we have derived this relation and it gives us P plus A prime times P prime. So the momentum operator B times P prime is P prime plus A prime minus B operator P prime. And this is a number. Why this is a number? Because this is a number, this is an operator which will give us P prime eigenvalue, which we have fixed from here. Okay, so okay, this basically means that B on P prime is giving us a shift of P prime minus A prime. Right? Or if you do the reverse of this, it is shifting like this. Okay, fine. Now let's try to look at the matrix element. So our interest is to find P prime, B, P prime alpha, and we know that what this will do is P prime plus A prime alpha. Right, so B dagger is basically B inverse. Okay, so and the appropriate operator would be here B dagger, and that would change here dagger minus A, because only the B dagger would operate here, right, as we have seen here. Okay, just a minute. Okay, B dagger would give us P prime plus A prime. Okay. Okay, I think I made slight mistake here. So this suggests that there exists an eigenstate like this. This is P prime minus A prime. So when B operates on P prime, it translates it by some amount of positive A prime, and if we do the reverse part, the B dagger, it does the negative translation. So when B dagger operates on P prime, it gives us minus A prime. Okay, sorry for this mistakes, and we can just write it as psi alpha P prime minus A prime. Okay, so when we do the Taylor expansion of function like this, what do we get? Psi alpha P prime minus A prime del by del P prime of psi alpha P prime plus of A square primes, which we are ignoring for time being. And similarly, if I write the actual form 1 plus I x A prime h bar alpha, this gives us, sorry, B dagger would be minus, so it will give us P prime alpha minus I A prime h bar P prime x alpha. Okay, so if we compare these two equations, and that would give us what? Psi alpha P prime plus I A prime alpha. Okay, so this would give us, so these both are same equations. If I compare both the sides, so psi alpha P prime minus I A prime h bar x alpha. These both term would cancel, A prime would cancel, so this gives us P prime x alpha is nothing but h bar I P prime psi alpha p prime. Okay, I think I made some mistake here. Okay, so I think I was able to identify my mistake, and very sorry for making such mistakes. So this is okay, this is so when B operates on P prime, it is giving me P prime plus A prime, and when I do the Hermitian conjugate of this, the cat becomes prey, this B becomes B dagger, and this remains same. Of course, this does not change. On the other hand, if I would have gone with B dagger on P prime, it will give me P prime minus A prime. Otherwise, this is only flipping signs. Okay, so if I write here B dagger, this will give me P prime plus A prime. This will become plus, this will also become plus, and hence this will lead to plus. So here it will be plus again, and this is wrong. I'll keep it here for the sake of completeness, to show that where I made the mistake. This becomes h bar on negative I psi alpha p prime. This is IH bar del p prime of psi alpha p prime. Okay, this is the right. Okay, so keep in mind how one small sign can make big differences. Okay, so I think we found this.